All right, so welcome back, everybody. So like I said, we'll be going over percent growth and decay models in this lesson, but let's begin by looking at the warm-up. So some of these were different approaches that you guys had to use. For example, the first question is fractional multiplication, 4 over 5 times 45. Keeping in mind that 45 is a whole number, so 45 has a denominator of what? Of 1. So this is 4 over 5 times 45 over 1. Sure, you can multiply it straight across. Hopefully you guys remember this from multiplying fractions, but you actually can reduce some numbers if you find a factor, a common factor. So here I know 5 goes into 5 once, and I know 5 goes into 45 9 times. So this I can rewrite as 4 over 1 times 9 over 1, which will give me 36 as my final answer. Now, that's if you use this approach. If you were using the approach from lesson 4.01, we are looking for a number, right? Number that plus itself 5 times gets you 45. What would that number be? Well, that number would need to be 9, since 9 plus itself 5 times is 45, right? 9 times 5 is 45. That would be the bottom number. And the top number, the numerator, tells you, well, how many of those do you want? Well, you want 4 of these. So 9, 9, 9, and 9 give you 36, which is how we get the same answer, right? So different approaches. The top approach is just doing it, normal fractional way. The second approach is using that method that we talked about in lesson 4.01, which is how we were able to solve for fractional exponents, okay? All right. What is the order here? Some of the numbers are weird. Let me move to number 3. So 32 to the 3/5 power. This denominator of 5 is telling you that some number times itself 5 times gave you 32. Well, what number would that be? Think about this number. So it's the same number, right? That would make this number 2. Well, 2 times 2 times 2 times 2 times 2 is 32. And the top number, the numerator, is telling you how many of these boxes you want. The numerator is 3, so it's telling you, well, you want 3 of these boxes. 2 times 2 times 2 is equal to 8. So that is our solution. Okay? So keep that in mind as you look at fractional exponents. The denominator tells you how many times this number multiplied by itself gave you the final answer. The numerator tells you how many of these boxes you want to ultimately get your solution, okay? All right, this one is a little tricky. There are 2 ways to do this. I'm just going to go ahead and tell you right now, you do not need to worry about this question. You will not see this on any sort of assessment, neither a quiz nor a test. But I guess the approach here is, all right, well, I want 2 groups of 20. And then I got to figure out 4 smaller groups that add to 20. So that would be, let me just do this here on the side, right? 3/4 of 20 would be some number plus itself 4 times. Well, that number would need to be 5. But my numerator is telling you I want 3 of these. So I'm going to do 20, 20 plus 5 plus 5 plus 5. This is equal to 40 plus 15, which is equal to 55. This is the approach, once again, using that idea of multiplication as repeated addition. The 4 being some number plus itself 4 times, that gave you 20. The 3 being, okay, I want 3 of these, and that's how you get the 15. The 2 is, 20 times itself, or 20 times 2 is just 20 plus 1. Okay? Like I said, don't stress about this one. This will not be on any assessment. And this is on tape, so you guys can quote me on that. All right, 9 to the 3/2 power. 9 to the 3/2 power. So once again, going back to the idea of Some number times itself twice, that gets you 9. Well, what would that number need to be? Not plus, I mean multiplying. 3. So 3 times 3 is 9. But my numerator is telling me I want 3 of these. So I actually want more than what I have. So I'm going to do 3 times 3 times 3 to get my final solution. 3 times 3 is 9. 9 times 3 is 27. So 9 to the 3 halves power is actually equal to 27. Keep that in mind as you work with improper fractional exponents. Improper represents a fraction where the numerator, the top number, is bigger than the bottom number. Okay, when you have that sort of example or problem, then that means that your final solution will be a number bigger than what you started with. Like in this example, our base is 9, but our final solution is 27. 27 is way bigger than 9. Okay, so it's not always going to be a smaller number. It all depends on your numerator. Okay? All right, let's finish up. 64 times, or to the 2/3 power. So here, this is a normal fraction. We should get a smaller number. We are looking for some number times itself 3 times. That gives you 64. That number is 4. 4 times 4 is 16. 16 times 4 is 64. My numerator is telling me you only want 2 of these. So I want to evaluate 4 times 4. That gives me 16, and that is my solution. All right? And let's finish up with number 6. 9 to the negative 3 halves power. We're going to combine a bit of, fractional exponents and negative exponents here. First things first, I need to get rid of that negative exponent. So 9 to the negative 3 halves will become 1 over 9 to the 3 halves. And what happened here was I took the reciprocal. I brought the 9 from the top and I threw it down to the bottom to the denominator, because that is the way that you are supposed to get rid of a negative exponent. Once you're at this step, then you can go ahead and use the fractional exponent rule, or the method there, to go ahead and solve for what you're looking for. So this is saying, let me erase this actually. I'm going to do the bottom by itself. So 9 to the 3 halves, which we did earlier, but 9 to the 3 halves is some number times itself twice. That gives you 9, and you want 3 of these. Well, we found 3 times 3 is 9. Well, 3 times 3 times, this is really small, let me write this. 3 times 3 times 3 is 27. So this right here that I'm highlighting in blue, I am going to replace with the number 27, since that is the equivalent to what we just did. So overall, your solution will be 1 over 27. That is your final solution. Okay. All right, and it's not that I'm jumping any steps here. It's just that I'm doing it separately. I'm evaluating 9 to the 3 halves separately, and then all I'm doing is, well, I'm going to take this 27 and replace 9 to the 3 halves with 27, since that's what we found out is equal to. Okay. All right, you can definitely expect a question like 3, 4, 5, and 6. At least one of those questions, or maybe 2 of those questions, on the quiz Friday, and definitely a few of them on your exam next week. Okay? All right. Please make sure you're following along as I go through this warm-up, since it has been quite some time since we've done this together. Okay? Number 5. As a benefit for its customers, Costco sells its products at a discount. For example, AirPods, regularly priced at $165, sell at Costco with a 12.5% discount. What is the Costco price for Apple AirPods without calculating in the tax? So I'll be sticking to just one way, because I believe this way that I'm going to show you right now is going to set us up for today's lesson. So I'll be ignoring the second way. So please go make sure you're following along. One of the first things you guys need to consider is, all right, well, what's the initial value of the item? The initial value is 165. Second thing we need to consider is we are taking into account a discount of 12.5%. So think about this. what percentage are you actually paying for or of the item, right? So 100% of the value would represent the 165, but we are not paying 100% of the value. We are paying at a discount. How much exactly? Well, we're taking away 12.5%. So in reality, what we're paying is we're paying 87.5% of the 165. That's what we want to figure out. Okay? So 87.5, we got to translate that. We got to translate that to a decimal. So that would be 0.875 times 165. And yes, you would need a calculator for this. That's why I let you guys use calculators on this warm-up. You're going to multiply the following numbers. This calculator doesn't work. Let's try this one. It's like all these calculators are broken. Okay. I'll use one of your guys's. Let me try this one. All right, perfect. So we have it right here. The final answer is $144 with approximately 38 cents if we round up. Should be 37.5, or 37.5, but we're not gonna include that third number. So anyway, you end up paying $144 if you go to Costco, which is great. Right, you're saving some money on that. Anyway, so what is the takeaway for this problem? Like I said, the takeaway is figure out that you're not paying the 100% of the original value. You're actually paying 87.5%, which is what we're going to multiply. When you multiply these two numbers together, you get your final answer like in one simple step. All right, let's do the last one. A 65 Mustang convertible in good condition is worth $19,400. If the value of the car increases by 8.5% each year, how much will it be worth next year? All right, simple. In this example, 100% of the value of the car, well, that would be the $19,400. But next year, it's going to increase in value by what percentage? 8.5. So is it still going to be worth 100% of its original value? No, it's going to be an increased amount. It's going to actually be worth 108.5 of the original value of the 19,400. So what do? We convert this percentage to a decimal. 1.085 times 19,400. And that's going to get us the following number. I'm going to use a different calculator this time. 1.085 times 19,400 gets you $21,049. So it will increase about close to $1,500 in a year. A little bit more than that. Okay. So once again, the idea here is we are not doing the discount separately. We are not doing the increase of value separately. We're doing it all in a single step, and that allows us to find our solution. Okay? All right. Are there any questions with the warm-up before we move on? All right. So this is what I want to do next. We have an accountability quiz. So you're going to work with your team, all right? Look at the instructions. It says, as you work with your teammates on this task, be sure that no one gets ahead or falls behind, and that everyone can explain anything that is written down on their paper. Be ready to explain your thinking to me. I want everyone to look at the first example. I'll read the first example for you. You guys are going to go ahead and fill out the rest of these tasks. But first example says the following. Lisa and Marcos were working on solving the following situation. The balance in a bank account with $300 earns 2% interest each year. What will the balance be after 5 years. Now, I will not set my timer up right now. I just want to see how you guys will work on this. So look at the tasks. This is a team task, by the way, so I do expect everyone to work together. And if you have questions, please call me or Ricky over. All right, go ahead and get started. Okay, so before I let you guys move on to the next question, I would like to go over part of this one just to make sure we're all on the same page of what I want you guys to accomplish or to learn from this example. Now, the task at hand, once again, was the balance in the bank account with $300 earns 2% each year of interest. Let me highlight that, 300 and 2% interest. What will the balance be after 5 questions? 5 years, I mean. Now, the first part of the question is looking at this equation. Y equals 300 times 1.02. Why are we multiplying by 1.02? We talked about, well, you know, as I went around each group, you guys mentioned how, well, there's a 2% interest. If it's just the 2% interest, we would be multiplying by 0.02. There is more than just 0.02. It's 1.02. And the reason why this happens is because each year, you are not just having 100% of the original value, you're adding on that interest. You're adding on the 2% to the 100% of the original value. So the 1, this is 100% of the original value. So that would be 100 plus 2%, giving you 102% or 1.02. The 300 is the initial amount of money, so it's $300. Okay. Now, if we multiply this out with a calculator or however you want to do it, 300 times 1.02 is 306. Now, what does this mean? This is the balance after how many years? This is not the balance after 6 years. So how many times did I multiply 300 times 1.02? I only multiplied it how many times? 1 time. Every time that you multiply it by 1.02 represents a year, and we'll see that later. But since we're just multiplying it by 1.02 once, this is the balance after 1 year. So the question is, did we answer or did we find the actual balance after 5 years? And no, we didn't. We found the balance after 1 year. Now think about why that is the case. Why is it that I would need to continue multiplying by 1.02 over and over again to represent the number of years? Well, think about it this way. On the first year, it's 102% of $300. The second year, it's 102% of whatever you got after the first year, which in this case we found was 306. So now it's not 102% of 300, now it's 102% of 306. The year after, it's 102% of whatever you got the last year. So it's always based on the year before, not on the initial amount of the 300 anymore. Now it's based on the year before. So look at what happens with the table. Like I said, year 0, you start with 300. Year 1, it's 306. Year 2, it's 312. Year 3, it's 318. The fourth year, that means we would need to multiply 300 by 1.02 4 times, right? Because we're taking 102% of the value from the previous year, which is 318. If we are doing a shorthand expression, remember that repeated multiplication is how we show an exponent? Well, anytime you multiply 1.02 by itself, you can just write that with an exponent. So that would be 300 times 1.02 to the fourth. And then 300 times 1.02 to the fifth. To the fifth. Oh, that's ugly. So how is the table related to the situation? Well, now this table actually finds the balance for each year. Okay? The table finds the balance for each year. How are the exponents in the expression column related to the values in the years column? So for year 1, what's my exponent? 1. For year 2, what's my exponent? 2. Year 3, my exponent is 3. Year 4, my exponent is 4. Year 5, my exponent is 5. You can kind of get the idea here that the year is directly related to the exponent. So it's directly related. Will completing the table answer the question in the problem? Yes. If we figure out what 300 times 1.02 to the 5th power is, we can essentially find our solution, right? Which in this case would equal what? Did anyone get that far? What would that equal? What is the final balance after the 5th year in actual dollars? 300 and what? The answer is 331.22. You would have got that solution had you multiplied 300 and then times 1.02 to the 5th. All right. So yes, it does answer the question. Whatever you guys chose to do as your explanation, I'll just leave that up to you guys. Now, look at the table, or look at the next question, the next prompt. Use the table Marco's made to write an equation that will model the bank account balance for any year. Well, we talked about, well, why would be the bank account balance? We start with $300, and it becomes apparent that we always are multiplying by 1.02. So we're always multiplying by 102% of 300. The problem is, how many times are we doing this? And that's where the exponent comes in, because depending on for what year you're trying to find is what the exponent will equal. Now, I will just leave it as x for now, but I want to make it clear that x represents the year. Okay? Now, this function in the next part, f of t, is something we are going to be using in this unit, or in this lesson today. Now, look at what this is giving, or this is telling you. Function f of t, or function t, is equal to a, parentheses, 1 plus r to the t. How is y equals 300 1.02 to the x equal to this function? Or, like, where do you see the similarities? Well, it's very clear that the value of a is your initial amount. We can see that because a is equal to 300. Now, 1.02, well, we know where the 1 came from. The 1 represents 100%. R represents your growth, or your interest rate. That's where the R comes from. We actually did 1 plus 0.02, giving us 1.02. And then T is time in years, or depends on how many times you're compounding this. But as we can see, it's all pretty much the same, right? So the T is equal to the X, and this is equal to that. Okay. All right. So hopefully this clarifies some of your questions or concerns for this part. We are going to work on the next example, and then we will take our break. I'll leave this up if you guys want to look back to this. Okay, so let's finish with this question, and that way you can take our break. Now, the new scenario follows the idea of a car that is originally $42,000 but depreciates 15% yearly. So we have the following table. The 0th year, it's worth $42,260. After 1 year, it went down to 35,921. Then it went down again the second year to 30,532 with 85 cents. The third year, if you follow the pattern, it would be 42,260 times 0.85 times 0.85 times 0.85, giving you the following: 25,952 with 92 cents. The fourth year, it would be worth 22,059 with 98 cents. The fifth year, it's only worth 18,750.99. And then finally, after 6 years, it's worth 15,938 with 34 cents, roughly adjusted. Now, if we're looking at the expression, think about the expression 42,260. We're multiplying it by 0.85, but in this case, the 0th year, we multiplied it 0 times. After 1 year, it's 42,260 times 0.85 to the first, right? The exponent represents the year, so it's to the first. Then we have 42,260 times 0.85 to the second. Then 42,260 times 0.85 to the third. 42,260 times 0.85 to the fourth. Then to the fifth, and then to the sixth. Where essentially the exponent represents the year, like I said. All right, so the exponent represents the year. Now, how come we're multiplying? Thank you. Thank you. How come we're multiplying by 0.85 and not by 15 or 0.15? Think about what the value of the car is year after year. It's depreciating by 15%. So we're subtracting the 15% from the 100%. This is 100% of the original value minus 15%, which gives you 85%. So year after year, you're taking 85% of the value from the previous year. That's why we multiply by 0.85 and not by 0.15. Okay? All right, help Destiny complete the table. We said the function would be y equals 42,260 times 0.85 to the x power, where x represents the year. The function for calculating percent decay is f of t 1 minus, or a 1 minus r to the t. How is your equation related? Well, we know that the a is 42,260. This is the original value of the car. The r is the depreciation, or the rate by which we're depreciating, which in this case was the 15%. And then x is time. Using a graphing calculator or Desmos to determine when the car will be worth 5,000. Let me go ahead and show you that right now. We do split view, and then let me open Desmos graphing calculator. Okay. So our function from up here is y equals 42,260 times 0.85 to the x power, and we want to figure out when that's equal to 5,000. All right, so let me make this a lot smaller. Y equals. There it is. All right, so let's find that point of intersection. Point of intersection is 13.13. So after about, 13.13 years. So when x equals 13.13 years is when it will be worth 5,000. Okay, let's finish off with just how do we tell when it's growth and when it's decay? So it's very simple. If the value that is in the parentheses is greater than 1, it's growth. If it's less than 1, it's decay. Okay, look at the first one. A, f of t equals 50 times 1.03 to the 10th power. Is this equation modeling growth or decay? Because that is 1 or greater than 1, this is growth. What is the percent increase or decrease? That would be 3%, right? The 1 is part of the equation, but the 0.03 represents 3%. What was the initial value? Initial value is 50. How much time have gone by in this model? The exponent is 10, so 10 of whatever, whether it be years, days, months, whatever. Next one, 375, 4. This is decay because the value in parentheses is less than 1. Now, it meant that we subtracted by 25%. Because if you subtract 0.25 from 1, that will give you 0.75. The initial value is 300 and 4 years have gone by. Next, we have decay again. This time we went down by 10%. The initial value is 175 and 7 of whatever time intervals have gone by. Next one is growth. Since the number in parentheses is greater than 1, it's actually a growth of 32.5%. And initial value is 25. 3 years or 3 of whatever time intervals have gone by. Next, we have growth again. The number in this case is 2 inside the parentheses, which is a 100% increase, right? 1 plus 1 is 2. That's how we get that. Initial value is 3,000 and 8 of whatever have gone by in this model. Okay. Make sure that this is written in your notes, and when we come back from a break, we will continue with the next portion. Okay, so the remainder of class, I'm just going to have you guys work on the red light, green light. Keep in mind that for each problem that you work on, you are supposed to write an equation and then use that equation to solve for the task at hand, okay? So we have about 25 minutes. Please call me over as you work on each problem, just to confirm that you're working on it correctly. All right, this time is yours.